Thank you, Matthew, for the opportunity for me to share with the world what Easy Water is doing as far as bringing clean water to communities with contaminated water sources, as well as no electricity. So as a group, as a research director for the group, I would like to share with you some few things that we are doing with regards to the research side of the project. So this will be the outline of our presentation this afternoon. Why the research, and then we talk about operational communities, and then so why the research? Okay, why the research? Before we talk about why the research, I think we should let the world know what Easy Water stands for. Easy Water aims to improve quality of water by providing purified drinking water in rural areas with contaminated water sources and no electricity power. So how do we accomplish this? We accomplish it by the use of a repurposed hemodialysis filtration system that makes use of hemodialyzers, the one that you use in the kidney dialysis. So why the project? As a way of serving as a quality check, that's to determine if the hemodialyzer filtration device fits for purpose, that's able to trap the waterborne disease causing organism due to its relatively small pore size of 0.003 microns. Again, we also seek to measure the impact on public health. Thus, we believe that once the filters are able to trap water-causing organisms, then it can prevent gastrointestinal diseases such as diarrhea diseases. Next slide. So these are the operational communities that we are currently operating in Ghana. In Ghana, at the moment, we have two main sites that the project is currently ongoing. That Adan site in the Greater Accra region of Ghana, and the Kumasi site that's in the Ashanti region of Ghana. So in all, we have about more than 20 communities that we are currently operating in. Move on. The next slide. So what methodology do we use in doing our research? Simply, before the device comes in, it has to be certified by Ghana Standard Authority. That's the nation's agency that determines that any device coming into the system are of good quality. So our device went through the same process and it was certified by Ghana Standard Authority. Secondly, because of the research component, there was a proposal or protocol to that effect. And that one has to also be reviewed and approved by Ghana Health Service Ethical Review Committee and a local IRB. So the local IRB that we are currently working with is Committee on Human Research, Publication, Ethics of KNUST, that's Kwame Nkrumah University of Science and Technology in Ghana. They have approved the study. So after the approval was set, we have trained data collectors to collect baseline and follow-up data using structured questionnaire at the household level. So what type of data do these guys collect? These guys collect data monthly on self-reported diarrhea of household members. Secondly, they also collect data on socioeconomic characteristics and risk factors for COVID-19 in the communities that we operate. We also trained device caretakers to take care of the device and report any problems that comes along that is associated with the device, and they're reported to appropriate authorities every month. So those device caretakers do that. And then you collate all those reports into what you call device problem log. These data are then managed by a RECAP platform, and analysis is always done with our software. What we also do, again, is that we have collaborated with Water Research Institute, that's Government of Ghana mandated institute in water research, to biannually collect water samples from our sites and analyze it to see if the water is of good quality that the people can drink. Next slide. So since the inception of the project, we have been able to publish 3 papers, a number of abstracts that have been presented to international conferences, both locally and internationally. So with regards to the published papers, the first paper that we published was entitled Public Health Benefits of Water Purification Using Recycled Hemodialyzers in Developing Countries. This one was published in a scientific report journal in 2020. So what this study seek to achieve was to determine if after the implementation of the device, diarrhea incidents have been reduced in these communities. And lo and behold, after the implementation, by the findings of the research, diarrhea incidents have been reduced. The second paper that was published in the same year in Water Supply Journal was entitled Purifying Polluted Water Through Hemodialysis Filters for Poor Villages Without Electricity, the Easy Water for Everyone approach and experience. With this particular sort of study, we sought to establish the processes that Easy Water use in going about its operations. That's by first identifying communities, and then secondly, we implement our hemodialyzer filtration system. And then secondly, this study also established that for the device to produce clean water in a day for communities with population less than 1,000 people, we need $2 to do that. And as part of the operations of the system, what we need is to push or transfer dirty water into an elevated tank, and by the use of force of gravity, the water is pushed through these hemodialyzer filters for clean water to be generated at the end. Next slide. So the last paper that we published recently was on long-term sustainability of using hemodialyzers to inexpensively provide pathogen-free water to remote villages lacking electricity. And this was published in Water Journal in 2022. With this particular study, what we seek to achieve was that over the 2 to 6 years that the device have been implemented in these communities, what has been the secret of ensuring its sustainability over the years in terms of its technical ability to produce these clean water? So this is what we sought to do with regards to this particular study. So what we determined was that the key thing that can contribute to the sustainability of the device in producing quality water is what we call backwashing, because at the end of the production of the clean water, the debris or unwanted materials are trapped in the filters, in the hemodialyzer filters, and to ensure the lifespan of these filters, what we seek to do is we have to get rid of these debris or unwanted materials. So the only way that we get rid of these unwanted materials is the use of what we call the backwashing, and people have been trained to do this. And so the minimum of backwashing that we do in a day to ensure the long lifespan of these filters is minimum of 3 times in a day. So that's what we do. Again, to those that were trained to man the device or take over the device, also make sure that when there is a problem with the device, they report to the appropriate authorities, and the appropriate authorities also make sure that once the problem is reported, prompt action is taken to resolve the problem. Next slide. So this table also looks at the articles and abstracts, as I said, that have been published and presented in international conferences so far. So as I earlier said, 3 articles have been published and 9 abstracts have also been accepted and presented in international conferences. Thank you very much.